What's going on, everyone? Welcome back. Patrick here. Moving on to the next question. So in how many ways can 8 students be assigned to 4 tutors if there are no restrictions on however many students a tutor can get? So this specific question here, you can actually show with a tree diagram. So I'm going to show it to you visually. We won't be able to do the full tree diagram because, as you'll see, there's going to be tons of branches, but I'll show you how you could start the tree diagram, and then I'll show you algebraically how to do it. So visually what happens is we have 8 students. We're going to assign them to 4 tutors. There's no restrictions also on however many students a tutor can get. So on an extreme case, there could be a case where one tutor gets all 8 students. Most likely going to be some kind of mix, but that can happen as well. That's what we mean by no restrictions. So there could be a case where one tutor gets all 8 students and then the other 3 tutors get no students. So to take all of those types of cases into account, what you would do is you would start a tree diagram with the first student. And the first student can be assigned what? One of 4 tutors. So there would be 4 branches, right? So we could have like tutor, let's call it tutor A, tutor B, tutor C, tutor D, right? 4 tutors. And then what would happen, the second student would also be assigned one of the 4 tutors. So we would have A, B, C, or D over here. So let's say that the first student picked tutor A. Well, now the second student can pick one of the 4 tutors. And then if the first student picked tutor B, then the second student again can pick one of the 4 tutors. And then if the first student picked tutor C, we'd have A, B, C, D, and then kind of running out of room here, but it would be so on and so on. And so notice that for the first student, there are 4 cases, but when we add the second student on, if you added up all of these, there would be 16 cases. And so notice that you're multiplying by 4 every time. And so you would keep expanding this tree, and then that extreme case where, for example, tutor A would receive all 8 students, it would be the branch, the topmost branch, that would just keep going like that, right? It'd be tutor A, the third student would pick tutor A, fourth would be tutor A, etc., etc. But what we got to do is for 8 students, so let's pretend that we keep going, how many branches would be at the 8th, not students, we're just looking at one student at a time. At the 8th student, how many branches would there be at the end? Well, there's 4 here, there's 16 here, and we keep multiplying by 4, so what is the pattern? Well, this, for the first student, it'd be 4 to the power 1. Once we add the second student, it'd be 4 to the power of 2, which is 16. Then the third student, it'd be 4 to the power 3, etc., etc. So the number of branches, once we add the 8th student, would be 4 to the power of 8 for the whole tree. And then 4 to the power of 8 would be 65,536. And so that there is the final answer. So a question like this, you may just see this 4 to the power of 8 be the answer. That's the solution that may be given. But to visually show what's going on, where this comes from is basically this entire tree. It's just this tree, especially if you're dealing with these kinds of numbers, would be really big to draw out. And so a lot of times the solutions just give the algebraic expression.